So warm welcome to the JDBC talk here on Graph Connect. So we're schedule is running a little bit late, so I'm starting 5 minutes later, so we'll probably spend 5 minutes in the end as well. I want to talk about the Neo4j JDBC Driver. Before getting into the details, a little bit about myself. I'm Stefan. I work for Neo for almost 5 years now as a field engineer. I'm based in Munich, Germany. And from the image, you can infer that my big hobby is I'm volunteer firefighters for more than 20 years now. You have all my contact details there. I will share the slides anyway, so if you get any questions after the show, please drop me an email, send me a tweet or whatever. Yeah, let's get started with the topic. So let's go a little bit back in history of Neo4j. So who of you has a history with Neo4j over longer than, let's say, 8 years? Okay, so no one has used the 0.x versions in the room. Historically, Neo4j was a kind of a library for the Java ecosystem that has a kind of in-process graph database. Yeah, at that point of time, you had no chance to access the database remotely. Then with the versions 1.x, the big innovation at the time being was there is a network. It's available to access the database remotely by a REST API. This is what if you remember this chatty REST API where you have granular calls for creating the node, setting a property. So you have a huge amount of calls for getting a little work done. So this turned out to have a very poor performance, but it was nice from an API design perspective, but it didn't really work out for large-scale operations. And then in the 2.x series, the most important part of the REST API was this transactional HTTP endpoint, which probably most of you know who are still working on 2.x. So you have you can communicate with that endpoint, you open a transaction, send some cipher, then you get back the result of that cipher statement. You can send another request to the same transaction, and at the end, close the transaction off. That was basically the way to communicate with the database remotely in 2.0. In 3.0, there was the invention of the Bolt protocol. So in addition to the REST API, we now have a binary interface. And I guess you learned all about how the drivers work and that we have a kind of unified driver for all kind of frameworks and languages available now. Just keep in mind that kind of history, because then some parts of what I tell you in the rest of this talk will become a little bit clearer. So let's get back to the REST API. So this is a kind of example how you did it with a transactional cipher endpoint. So you send a request to data transaction, or if you want to close the transaction in the same request, do data transaction commit, send here in the JSON document the cipher you want to have executed. You could easily supply multiple statements, and then for each of the statements you get back a result. And here we get the IDs 60 back from the server. In Bolt, the communication looks roughly like that. So you open a graph database. On a graph database, you acquire a driver where you specify where your database is located, how you can access it. From the driver, you acquire a session. In the session, you execute a cipher statement. You can also use parameters. This is not in the example here. And then the statements basically give you back a statement result, which you can iterate and consume. That is how you work in 3.0 with the driver. And that code looks pretty much the same on all the languages. Okay, so who of you is somehow familiar with JDBC API? Okay, some of them. So you will notify that we have a database, we have a session, we have a result. That somehow fits the API language of JDBC. In fact, JDBC is specified in a JSR. It's JSR 221. Currently, the most recent is version 4.1. The document, the PDF, has 220 pages, so it's far from being something lightweight. There is, from Oracle, there exists a kind of TCK for that, but that one is not publicly free available. At least I didn't find it. Almost all vendors of relational databases support a JDBC driver somehow. And interesting, also a lot of non-relational data stores feature JDBC these times. So I learned that Elastic has a JDBC driver, for Hive is something. So JDBC seems to be an interesting technology for accessing data. The reason for that is because there is a huge existing ecosystem with client applications. So almost any kind of BI tool or ETL tool does somehow support JDBC. And this is the reason why we said, well, we want to have JDBC for Neo4j as well to enable integration with all the existing tools out there. So the architecture of JDBC roughly looks like that. So we have on the top layer a client application that speaks to the JDBC API. Underneath, as an implementation part, there is a driver manager, which manages all the drivers that connected and load the stuff from there. And then each database vendor or each database has its own JDBC driver that is then plugged to the driver manager. And if we want to add Neo4j to that game, we have a Neo4j JDBC driver that then communicates with the graph database. Okay, so there was back in 2012 by a colleague of mine, Rickard, a kind of proof of concept to implement JDBC on the REST layer. This implementation was tightly bound to the REST API, to a REST implementation. It even uses a library called RESTlet, which was not part of the Maven Central repository at the time being. Therefore, we couldn't deploy that JDBC driver to Maven Central either. It also had some performance issues. As said, it was more a kind of proof of concept-like thing. You can still find the code for that old REST-based JDBC driver on GitHub under Neo4j JDBC 2x. Please don't use that anymore. It's historic. It's not maintained anymore. It's just there to stay. So the goals that we wanted to achieve with the new JDBC driver, of course, we wanted to support as many clients as possible. And this is already the challenging thing here because the specification is huge. And each of the tools uses a certain subset of that. So implementing all of the specification is probably way too much. And also a graph database does not fit in every piece of the JDBC specification because that is designed with relational databases in the background. So there is a lot of information about the schema which we simply don't have. So I can tell for a given table which fields that table has and what the type of the fields there is and if there are constraints on that. That is something that the graph database simply doesn't know. The second goal we want to achieve, we wanted to have a kind of multi-module way of doing that. So we should be able to let the JDBC driver talk bold or talk it HTTP or talk it on a file base. So the JDBC driver spawns the database internally. Or even embedded, probably there's this test graph database service which runs mostly in memory for testing purposes for small data sets. That is something we want to support as well. Of course, it should be as performant as possible. So what we wanted to achieve is we want to be on par performance-wise with the Bolt protocol, that the overhead is almost close to zero. As I said, we implement the specification where it makes sense, and at the end, the JDBC driver should become a first-class citizen of the Neo4j ecosystem. So what we did, there is a consultancy in Italy called Larus BA, Larus Business Automation, run by that guy, Lorenzo. He's the CEO of that company. And he said, okay, I'm partner of Neo since a couple of years, a good friend of mine. And he basically said, okay, I want to sponsor the development of that driver. And then 4 of his developers, Mauro, Marco, Alberto, Gianmarco, who work for Larus, basically wrote most of the code. From the Neo side, my colleague Michael, you know, all of you know Michael, I guess, acted as a kind of project lead or advisory role. I helped also in terms of testing, setting up build system and stuff like that. And then we have my colleague from France, Benoit. He contributed the HTTP binding. And then we had a guy from Germany who is an expert in BI tools. He knows Tableau and ClickSense in and out and helped a lot with testing these tools. And all this collaborative work basically led to the JDBC driver as we have it today. So the first public release of version 3.0, we tried to align the version numbers with Neo4j release to make it more easy to find the right version, was released back in July. It is a basic implementation, so just what's necessary to make it working with a lot of tools. From the modules, we implemented Bolt and HTTP/REST. So file and embedded is still on the roadmap. The main goal was to play nicely with common used JDBC applications. For you as a customer or if you want to use it seriously, the JDBC driver is fully commercially supported if you have a license agreement with us. So it's part of the regular SLA. You can download the driver either directly from GitHub or via Maven repositories. Yeah, so the architecture internally is roughly like that. So we have a module, Neo4j JDBC, that contains functionality that is independent of the transport layer. Then we have the Bolt binding, which uses the Java Bolt driver under the hood. And we have a HTTP binding, which uses Apache HTTP client under the hood to communicate with the database. The JDBC file and JDBC memory are on the roadmap, as said, but they will basically start the Neo4j instance internally. So they don't connect to a remote process. They use it, spin up the database themselves based on a given GraphDB directory. Yep. That is one use case, or the other use case is there might be infrastructures where only HTTP is allowed because Bolt doesn't allow for deep packet inspection, and if you have a kind of security policy in place where you want to have only protocols where the firewall can make sense out of that, then you need to go that way. But I think the mostly used part is by default the Bolt protocol, unless you have a good reason to go away from that. Not so much, basically. The overhead of HTTP is larger than Bolt, of course, but it's not so much. Of course, if you send a huge number of tiny cipher requests, the overhead will become large. But if you have large operations and only few of them, the relative overhead is neglectable. Okay, so a quick overview of the artifacts on Maven and the drivers. So if you want to use the Bolt version, the artifact is Neo4j JDBC Bolt for Maven, or if you use Gradle. By the way, who prefers Gradle? Who prefers Maven? Maven? Okay, Gradle? Okay, I'm on the Gradle side, sorry. Minority. Yeah, that's the same information here. And the driver's name is org Neo4j JDBC Bolt driver. The same, similar for HTTP. And there's also one bundle where all the drivers are bundled into one module. So if you just grab that one, you're on the safe side and can change over whenever you like. This org Neo4j JDBC driver delegates to the Bolt driver if possible, otherwise it chooses the HTTP. So that one is the option you want to choose if you don't want to think about it. Okay, so the roadmap for the future is, currently we don't have support for metadata. So JDBC supports a call for listing all the tables. We want to mimic that to list all the labels, because label and table is somehow a little bit similar. We also want to infer the table schema from properties being used and the constraints that exist in the database. Of course, this can never be a full 100% match, but I think we can get close to that. Then we want to implement the file module, where in the JDBC connect string, you just provide the GraphDB folder, and then it spins up the database on top of that by the driver. There should also be a kind of in-memory module, which is intended for testing purposes. And the last point is pretty interesting. If you use a couple of existing tools, they will send SQL under the hood. Maybe by just clicking something, they produced SQL and sent that to Neo4j. Since the JDBC driver is just normally is using Cypher, it kind of makes sense out of SQL. So we want to have a kind of basic converter that takes certain classes of SQL statements and converts them to Cypher where appropriate. So if you do a select star from table, that would be match, label, return, star. So for a couple of statements, I'm pretty sure we find a good mapping here. But that's getting really interesting project here to have that conversion from SQL to Cypher in the driver directly. So just to have the mental bridge between the Bolt protocol and JDBC. So what in Bolt is the graph database, in JDBC is referred to the driver manager. From the driver manager, you acquire a connection, which would be a session in Bolt world. For the statement in JDBC, we don't have a exact class mapping, but for the result set, that refers to the statement result. So it's just if you know one API, you can easily infer what in the other hand side is referred to. Okay, so let's look at some code. So this is a kind of minimum example in Java, how to use JDBC. Here we're having the driver manager. We open a connection to JDBC Neo4j Bolt localhost. That means we're communicating to the local instance via Bolt. On that, we create a prepared statement. And I guess you all know a parameterized Cypher, where you have this curly braces syntax to introduce parameters. If you use this in JDBC, the parameters can only be numbers. It cannot be any names. That is a limitation of the JDBC specification. And here you bind the parameter number 1 to value matrix. So you basically here look for all the people who acted in the matrix. And then you execute that query, you iterate over the result and consume the result here. That's classic JDBC code. It wouldn't look different for if you do this versus Oracle or MySQL. Second example, my preferred language is Groovy. Any Groovy fans in the room aside from myself? Wow, cool. So it does apparently the same thing as the previous slide, but it's much less code, much less boilerplate. Okay, but talk is not about how cool Groovy is. One important notice here is Groovy has a SQL abstraction called the Groovy SQL, and colon something has a special meaning there. So if you use labels and relationship types, be sure to put them into backticks if you use the Groovy part. Okay, yeah, that was the comment about backticks. So we have a couple of applications tested with the Neo4j JDBC driver. They're listed there. This list, of course, gets amended continuously. And the rest of the talk, I want to show a couple of these tools in a live demo version, how they interact with a graph database. Yeah, one meme must be in every slide deck, right? Okay, so I think first let's look at IntelliJ, my favorite IDE. So you have, of course, IntelliJ has a graph database plugin that I installed. But if you cannot use that for whatever reason, you can go back to the regular database JDBC plugin. There is here a button where you can configure the driver setup, and I already prepared here Neo4j setup. So what you basically need to specify is the location of the jar file containing the driver and the driver's name. Yeah, you don't need anything on the advanced tab here. And from that, you can then add a database connection. And I want to have a Neo4j connection. And then I need to specify the username. That's a Neo4j, my secret password 123. And we have as a URL JDBC colon Neo4j colon bold localhost. We want to test the connection. Okay, successful. Okay, and now I have here a kind of shell where I can enter SQL in the same, but this is the place to put my cipher code on here. So if I want to do, let's say want to match person, return p name limit 20. Let's just run that. We need to highlight it. And here we have some data from, so the graph database that I'm using under the hood. Let me just go there. I've added, so my colleague Rick put the agenda for today's conference into the graph database, and I just shamelessly copied that from Rick. So we have here all the speakers, all the sessions, and all that kind of information. And I just did here a query on the people, on the speakers that we have in the database. Okay, the next tool I want to briefly show is SquirrelSQL. Oh, I need to restart it. Didn't. It's one of the most frequently used database tools for relational databases, and its architecture is pretty much the same as in IntelliJ. So we need to manage the drivers and add a new driver. Let's call it Neo4j. Example URL, that's the connect URL is JDBC Neo4j bold localhost. And then as we need to have on extra class path. Where do we have that? That was in the download directory. Download, oh no, not here. Downloads, there is JDBC. And then we have here the Neo4j driver jar file. Let's remove that one. And if we list drivers, yeah, we already find here the driver name. Okay, and then we can create a database alias for our local Neo4j database. It's a Neo4j, and we just need the username, Neo4j 123. Okay, connect. There's some, yeah, the database driver is not JDBC 2.1 compliant because some of the meta info. So at that point, SquirrelSQL tries to fetch some metadata, and of course the database driver says, oh, I don't have that. And therefore we get this error message here. But we still can run queries here. Let's just get 10 nodes. Yeah, if you return nodes, it's an unknown type so you want to have projections. So again, let's go to, oh, sorry, I didn't see that the resolution really sucks for that tool. But if we want to get the name, yeah, we get here the names of the people. Oh, that's really, let's switch over to the next tool. I want to show something on the Windows machine here. I'm not sure if I can zoom that. It's called QlikView. QlikView is one of the BI tools. Who knows QlikView? Okay, so I know it since 2 days, or I use it since 2 days, so I'm not very proficient. I had this morning a call with Ralph Becker, who instructed me how to use it with JDBC. So the company that Ralph is running, it's called Tick Consult. They offer as a product a JDBC integration for QlikView. And I installed that, installed the JDBC driver, And if we go there, we open up the kind of, we can look at the data load editor. Yeah, sorry. That doesn't work from the resolution. Let me just see if I can go down a little bit with the resolution. That was here. Okay, let's go down to Doesn't look better. Looks different. Yeah, sorry, there's something pretty wrong now. Let's go back to, oh my God. Yeah, I think, yeah, so you can do basically the same. What? So black magic? Holy shit. Oh, Demo God doesn't like me today. Sorry. Let's unzoom that. And let's zoom that again. Okay, so this is the QlikView again. And so the trick is you need to have a custom connect script here. It says basically that you use here this JDBC connector from Tick Consult, and then you can run cipher statements. So this is a cipher statement. You cannot see it, but we can go back here. Let's go there to the data app overview again. And what you see here is, so this is basically just a quick aggregation of all the people in the movie data set and the year where the movie was, so it's about the movies and the year when it was started. So it's just the data set of a very simple data set that is just shown here in QlikView. Sorry for the bad resolution here. I have no idea why this sucked. Let's just close that one off. And the next tool I want to briefly show is Zeppelin. Who of you knows Apache Zeppelin? Yeah, it's a really cool tool. That is a kind of notebook application for big data world. So I have it here. Okay, so you can store multiple notebooks. I created a kind of mini dashboard with one single query. So I've here, basically I'm looking for the for the tags associated with all the talks and rank them by popularity in terms of sessions. And you can easily switch to some visualization mode here. And the way this is configured is in Zeppelin you have interpreters. And there is an existing JDBC interpreter, which are basically used for creating a JDBC interpreter here. And that one just has the usual configuration options, so the JDBC URL, the driver class name, credentials. And the cool thing is, for Zeppelin, you don't need to download the JDBC driver manually. You just need to specify the artifact in Maven notation, and then it downloads it directly from Maven Central. That was really cool to get that working. And I just learned about Zeppelin last week on a conference. This is on my agenda for next week to learn much more about that tool, because for me this sounds like it's a perfect tool if you have a kind of proof of concept with the customer and you need to do something out of the data, create a quick dashboard without hassle, then that tool sounds like a really powerful thing. Okay. So I'm almost done. Let me just see if I forgot something. No, I'm basically done at that point. we have some time for one or the other question. If not, I think the break is already there, and in Sweden we call this fika. So have some. Yeah, there's a question.
I went to JDBC, but does it take you one step closer to having a native Tableau driver?
What, a native?
Native Tableau, just like a
Tableau driver. There is some work going on together with Tableau, which is, I think, not based on the JDBC stuff. It seems to be more the direct thing.
Yeah, based on something.
Yeah, probably based on the Bolt driver directly. I'm not directly part of that, so I can hardly comment on Tableau driver. Yeah?
Yeah. About ClickSense, show us the connection part.
Yeah, the problem is the resolution, so please come over, we look directly at a laptop computer here.
I'm going to hand out this.
Can you use the microphone, please?
I'm going to hand out this microphone.
So like one of the drawbacks of Zeppelin is like the visualization is limited. So using Neo4j, like can you also provide some more visualizations in Zeppelin for graphs specifically?
Yeah, there is in Zeppelin currently no graph-specific visualization. I think this needs to be a kind of add-on to the interpreter. As I said, I just learned about Zeppelin last week, so I need to drill into but I think it should be easy to extend. So currently we have their different visualization modes. Let's go back to the dashboard here. So we have here a chart, a pie diagram, some other histogram-like, and I think we should add a kind of node and relationship-like style where you can really then explore the graph visually. That could be a nice pet project for the future for me, yeah.
And there are such extensions in ClickSense for network analysis.
Okay, if there are, wonderful.
Yeah.
As said, I don't use the BI tools myself. I'm more focused on hacking the JDBC driver.
And about you mentioned T-Consult driver.
It's a kind of what these guys have is they have a kind of JDBC connector together with QlikView and ClickSense. So by default, Qlik software doesn't support JDBC. They only support relational database by ODBC.
Oh yes, this is a bridge.
It's a bridge to that enables JDBC for the Qlik software, and in that one we can hook the JDBC driver to Neo4j.
And this was called TIQ before. That's it.
TIQ Consult.
Yeah. Okay.
It's Ralph Becker is the CEO of that company. I can give you the contact if you want to. Any more questions? Okay. Thank you. Let's go for fika.